Imagine a world covered in ice, glaciers 2 miles thick, stretching from the North Pole down to where New York City stands today. Mammoths roaming across frozen tundra. Saber-toothed cats hunting in forests that no longer exist. Giant ground sloths the size of elephants. Cave bears larger than modern grizzlies. This was Earth, just 12,000 years ago. A world so different from ours that it seems almost alien. And then, in what seems like an instant in geological time, everything changed. The ice began to melt, rapidly, catastrophically. Sea levels rose by more than 400 feet. Entire landscapes were drowned. Massive floods reshaped continents. The climate shifted so dramatically that ecosystems collapsed. And the megafauna, those magnificent giant animals that had dominated the planet for millions of years, vanished. Most of them gone within just a few thousand years. This was not a gradual transition. This was a crisis, a planetary upheaval, the end of an era that had lasted over 100,000 years. The Ice Age was ending, and the world that emerged from beneath the ice was completely new. It was the world that would give birth to civilization, to agriculture, to cities, to everything we recognize as human society. But before any of that could happen, the old world had to die. Today we will explore what happened during this incredible transition. What was the world like at the height of the last ice age? What triggered the sudden warming? How fast did the ice melt? What were the floods like? Why did the megafauna disappear? And what role did humans play in all of this? These questions have puzzled scientists for generations. And while we now have many answers, the story is far more complex and dramatic than most people realize. This is not just ancient history. This is a story about how quickly our planet can change, about how fragile ecosystems are, about how species that seem invincible can suddenly vanish, and about how humans, even with primitive technology, can have an enormous impact on the world around them. Understanding what happened 12,000 years ago helps us understand what is happening today, because in many ways, we are living through another period of rapid change, another moment when the old world is ending and a new one is being born. The end of the Ice Age was one of the most dramatic transformations in Earth's recent history. It reshaped continents. It redrew coastlines. It changed the distribution of plants and animals across the globe. It forced our ancestors to adapt or die, and it set the stage for everything that came after. Without this transition, without the end of the Ice Age, human civilization as we know it would not exist. We would still be small bands of hunter-gatherers, living in a frozen world, struggling to survive. But that is not what happened. The ice melted, the world warmed, and humanity seized the opportunity. We domesticated plants and animals. We built permanent settlements. We developed agriculture. We created complex societies. All of this became possible because of the end of the Ice Age, because of that moment 12,000 years ago when everything changed. So let us go back. Let us see what that world was like. Let us witness the transformation. Let us understand how we got from there to here. This journey will take us through time. We will see glaciers that covered half the northern hemisphere. We will meet animals that seem like creatures from fantasy. We will witness floods that make modern disasters look trivial. We will explore the mystery of why so many species vanished. And we will see how our ancestors survived and adapted to a world that was changing faster than anything they had ever known. This is the story of the end of the Ice Age, and it is one of the most important stories in human history. Before we begin, let me set some context. The Ice Age we are discussing, the last glacial period, was just one of many ice ages in Earth's history. Our planet has experienced numerous glacial periods over hundreds of millions of years. But this one is special to us because it is the most recent, and because modern humans lived through it. Our ancestors witnessed its end. They experienced the transformation firsthand. Their stories, passed down through generations, may be preserved in myths and legends that persist to this day. When we talk about the Ice Age ending, we are really talking about a transition from one climate state to another, from glacial to interglacial. This transition took several thousand years, but within that time frame, there were moments of extremely rapid change. Temperatures that shifted by 10 degrees in decades, sea levels that rose by feet per year, events so dramatic that they reshaped continents. These were not gradual processes, but catastrophic events, and understanding them helps us understand the climate system we depend on today. The world at the height of the Ice Age. Let us set the scene. 20,000 years ago, Earth was in the grip of the last glacial maximum. This was the coldest point of the most recent Ice Age. Ice sheets covered enormous areas. In North America, the Laurentide ice sheet stretched from the Arctic Ocean down to where Chicago is today. It was over 2 miles thick in places. 2 miles of solid ice. The weight of this ice was so enormous that it compressed the Earth's crust, pushing it down into the mantle below. In Europe, the Fennoscandian ice sheet covered Scandinavia, northern Britain, and much of northern Europe. In Asia, smaller ice caps covered the mountains and high plateaus. In the southern hemisphere, ice covered Antarctica completely, and glaciers in Patagonia were far more extensive than today. This was a world dominated by ice. Approximately 1/3 of Earth's land surface was covered by glaciers. Compare that to today, when about 10% is covered by ice. And all that ice had to come from somewhere. It came from the oceans. Water evaporated from the seas, fell as snow, and piled up on land as ice, year after year, century after century, for thousands of years. The result? Sea levels were approximately 400 feet lower than today. 400 feet! That is taller than a 40-story building. Coastlines were completely different. Land that is now underwater was dry. Entire continental shelves were exposed. The Bering Strait between Asia and North America was not water. It was land. A broad plain called Beringia, hundreds of miles wide, connected the two continents. This was how humans first reached the Americas. They walked. Britain was not an island, but connected to Europe by a land bridge called Doggerland. Indonesia, Malaysia, and much of Southeast Asia formed a single landmass called Sundaland. Australia and New Guinea were connected as Sahul. The world map looked completely different. The climate was harsh. Global average temperatures were about 10 to 15 degrees Celsius colder than today. But the cold was not evenly distributed. Near the ice sheets, temperatures were extreme. The edges of the glaciers were polar deserts, windswept and barren. But farther from the ice, conditions varied. There were vast grasslands, called mammoth steppes. These stretched from Western Europe across Siberia to North America. Dry, cold grasslands that supported enormous herds of large animals. And what animals they were. This was the age of megafauna. Megafauna means large animals, typically those weighing over 100 pounds. But many Ice Age megafauna were far larger than that. Mammoths stood up to 14 feet tall at the shoulder and weighed up to 12 tons. They were covered in thick fur, adapted to the cold. They used their enormous curved husks to sweep snow aside and reach the grass beneath. Herds of mammoths migrated across the steppes, following the seasons, just as caribou do today. Mastodons, relatives of mammoths, lived in forests and browsed on leaves and branches. They were shorter and stockier than mammoths, with straighter tusks. Woolly rhinoceroses, covered in long brown fur, grazed alongside mammoths. They had 2 horns, the front one sometimes over 3 feet long. Giant ground sloths, some species as large as elephants, lived in the Americas. They could rear up on their hind legs and use their massive claws to pull down branches. Glyptodons, armored mammals that looked like giant armadillos the size of a car, roamed South America. Their shells were made of bony plates, strong enough to protect them from most predators. Giant short-faced bears in North America stood 12 feet tall when on their hind legs and could run at speeds over 40 miles per hour. They were among the largest predators ever to walk the earth. Saber-toothed cats, with their distinctive long canine teeth, hunted across the Americas and Eurasia. These were not just larger versions of modern cats. They were specialized predators, using their saber teeth to deliver killing bites to large prey. Cave lions, larger than modern African lions, hunted in Europe and Asia. Cave bears, massive omnivores, hibernated in caves throughout Europe. Some caves contain the bones of hundreds of cave bears that died during hibernation over thousands of years. In Australia, the megafauna was even more bizarre. Giant kangaroos over 6 feet tall. Diprotodon, a wombat-like creature the size of a hippopotamus. Thylacoleo, a marsupial lion with retractable claws, and one of the most powerful bites of any mammal. And the giant monitor lizard, Megalania, possibly over 20 feet long, the largest venomous animal ever known. This was a world of giants. A world where animals grew to sizes we can barely imagine today. But it was not just the land that hosted megafauna. The oceans were also home to giants. Giant elk, also called Irish elk, though they lived far beyond Ireland, had antlers spanning up to 12 feet across. These were the largest antlers of any known deer. The animal itself weighed up to 1,500 pounds. Imagine seeing this creature walking through a forest, its massive antlers wider than a car. And then there were the humans. Modern humans, Homo sapiens, had spread across most of the world by this time. We had reached Europe, Asia, Australia, and were just beginning to enter the Americas. We were not the only humans, though. Neanderthals still survived in pockets of Europe, though they would disappear by around 40,000 years ago. We were hunter-gatherers, living in small groups, following animal migrations, gathering plants, fishing, adapting to different environments. Our technology was sophisticated for the time. We made complex stone tools. We had spears, some tipped with carefully crafted stone points. We had atlatls, spear throwers that increased the power and range of our throws. We made clothing from animal skins, sewn together with bone needles and sinew thread. We built shelters from mammoth bones and hides where wood was scarce. We created art, cave paintings, carved figurines, decorated tools. We had language, culture, religion. We were fully human, but we were not dominant. Not yet. We were just one predator among many. We competed with wolves, cave lions, hyenas for prey and territory. The megafauna were dangerous. A mammoth could kill a human with a single strike. A short-faced bear would see humans as potential food. We survived through intelligence, cooperation, and adaptability. We were clever apes in a world of giants. This was the world at the height of the Ice Age. This was the baseline. This was normal, the only world these humans had ever known. But it was about to change, dramatically, irreversibly, forever. The trigger, what caused the warming? So, what happened? Why did the Ice Age end? This is one of the most important questions in climate science. And the answer is complex, involving multiple factors that reinforced each other. Let us start with the primary driver, changes in Earth's orbit and tilt. These are called Milankovitch cycles, named after Serbian scientist Milutin Milankovic, who described them in the early 20th century. Earth's orbit around the Sun is not perfectly circular. It is slightly elliptical, and the shape of this ellipse changes over a cycle of about 100,000 years. Earth's axial tilt, the angle at which our planet tilts relative to its orbital plane, varies between about 22 and 24.5 degrees over a cycle of 41,000 years. And Earth wobbles on its axis like a spinning top, a movement called precession, which has a cycle of about 26,000 years. These cycles affect how much sunlight different parts of Earth receive at different times of year. They do not change the total amount of sunlight Earth receives, but they change its distribution. When northern hemisphere summers receive more intense sunlight, ice sheets melt more in summer than they can grow in winter. When northern hemisphere summers are cooler, ice accumulates year after year, and glaciers expand. These orbital cycles are the pacemaker of ice ages. Around 15 to 20,000 years ago, the orbital configuration began to favor warming. Northern hemisphere summers were receiving more sunlight. The ice sheets began to melt. But here is the crucial point. The orbital changes alone cannot explain the speed and magnitude of the warming. Something else amplified the effect. That something was greenhouse gases, particularly carbon dioxide and methane. And this is where the story gets interesting. Ice cores from Antarctica and Greenland provide an incredibly detailed record of past climate. Scientists can drill deep into the ice, extracting cores that go back hundreds of thousands of years. Each layer of ice contains tiny bubbles of ancient atmosphere, trapped when the snow fell and compressed into ice. By analyzing these bubbles, we can measure the exact composition of the atmosphere at different times in the past. It is like having a time machine. What these ice cores show is remarkable. As the Ice Age ended, carbon dioxide levels rose dramatically. During the Ice Age, CO2 was around 180 parts per million. By the time the Ice Age ended, it had risen to around 280 parts per million. Methane also increased significantly. These greenhouse gas increases amplified the initial orbital warming. Here is how it worked. As orbital changes caused some initial warming, ice began to melt. As ice melted, darker land and ocean surfaces were exposed. Dark surfaces absorbed more sunlight than white ice and snow. This absorbed heat caused more warming, which caused more ice to melt. This is called a positive feedback loop. More warming leads to more melting, which leads to more warming. This is the ice albedo feedback, and it is extremely powerful. As the oceans warmed, they released dissolved carbon dioxide. Cold water holds more dissolved gas than warm water. As ocean temperatures rose, CO2 bubbled out of the ocean and into the atmosphere. More CO2 in the atmosphere meant more greenhouse warming, which warmed the oceans more, which released more CO2. Another positive feedback loop. These feedbacks amplified the initial orbital forcing by a factor of several times. Methane also played a role. Methane is produced by bacteria in wetlands by decomposing organic matter in the absence of oxygen. During the Ice Age, much of the world was dry or frozen, and methane production was low. As the world warmed and ice melted, wetlands expanded. More wetlands meant more methane, and as permafrost began to thaw, organic matter that had been frozen for thousands of years began to decompose, releasing methane and CO2. Again, a feedback loop. There were also changes in ocean circulation. During the Ice Age, the Atlantic meridional overturning circulation, the system of currents that includes the Gulf Stream, was weakened. As ice melted, this circulation strengthened, bringing warm water from the tropics to higher latitudes. This distributed heat more effectively around the planet, accelerating warming in regions far from the tropics. The climate system is interconnected. Changes in one part of the system affect other parts. But the warming was not smooth or gradual. It was punctuated by sudden events. The most dramatic of these was the Younger Dryas, a period of rapid cooling that interrupted the warming trend. Around 12,800 years ago, just as the Ice Age seemed to be ending, temperatures suddenly dropped back to near glacial conditions. This cold period lasted about 1,200 years before warming resumed even more rapidly than before. What caused the Younger Dryas? The leading hypothesis involves the catastrophic drainage of glacial Lake Agassiz. This was an enormous lake formed by meltwater trapped behind the retreating Laurentide ice sheet in North America. It was larger than all the modern Great Lakes combined. At some point, the ice dam holding this lake broke. Massive amounts of fresh water, possibly released in a matter of weeks or months, flooded into the North Atlantic. This fresh water was less dense than salty ocean water. It formed a layer on top of the ocean, disrupting the Atlantic circulation. The Gulf Stream weakened, or even shut down temporarily. Heat was no longer transported from the tropics to the North Atlantic. Europe and North America cooled rapidly. This triggered a brief return to Ice Age conditions, but it was temporary. Once the circulation reestablished, warming resumed with even greater intensity. Some scientists have proposed an alternative or additional trigger for the Younger Dryas: an extraterrestrial impact. The hypothesis suggests that a comet or asteroid broke up in the atmosphere over North America, causing widespread wildfires, ejecting dust into the atmosphere, and potentially triggering climate change. Evidence for this includes a layer of sediment enriched in platinum and other materials typical of extraterrestrial objects found at sites across North America and Europe, dating to the start of the Younger Dryas. This impact hypothesis is controversial. Many scientists question the evidence and argue that the glacial lake drainage is sufficient to explain the Younger Dryas. But the debate continues, and new evidence is still being gathered. What is certain is that something caused a dramatic, sudden cooling event right in the middle of the deglaciation. And when it ended, the warming resumed faster than ever. Within decades, temperature shot up, the ice melted rapidly, and the world transformed. The Great Melt, Ice sheets collapse. Now let us talk about the ice. Because the melting of the ice sheets was not a slow, gradual process. It was catastrophic. Imagine ice 2 miles thick, covering half of North America. Now imagine it melting, not over hundreds of thousands of years, but over thousands of years. In geological terms, this is incredibly fast, and the consequences were extraordinary. Let us understand the scale of what happened. The Laurentide ice sheet, which covered most of Canada and the northern United States, contained an enormous volume of water. Estimates suggest around 30 million cubic kilometers. To put that in perspective, if that ice melted today, it would raise global sea levels by about 200 feet, and it all melted within about 10,000 years. That is an average rate of 20 feet per 1,000 years, or about 2.5 inches per decade. That might not sound like much, but it was enough to transform the world. But the melting was not steady. There were periods of rapid melting, called meltwater pulses, when sea levels rose very quickly. Meltwater Pulse 1A, which occurred around 14,600 years ago, saw sea levels rise by more than 50 feet in less than 500 years. That is over 1 foot per decade. Coastlines retreated rapidly. Low-lying areas flooded. Entire ecosystems drowned. For people living near coasts, this would have been a visible, measurable change within a human lifetime. How does an ice sheet melt? It happens from multiple directions. The surface melts in summer as temperatures rise. Meltwater flows in streams and rivers on the ice surface, eventually draining off the edges or down through crevasses into the ice. The edges of the ice sheet, where the ice meets the ocean, break off in huge chunks, a process called calving. These icebergs drift away and melt in the ocean. And from below, as ocean water warms, it melts the underside of ice shelves, causing them to thin and eventually collapse. The collapse of ice shelves is particularly important. Ice shelves are floating extensions of ice sheets. They act like buttresses, holding back the ice on land. When an ice shelf collapses, the land-based ice behind it can flow more rapidly into the ocean. This is what seems to have happened during periods of rapid sea level rise. Ice shelves collapse suddenly, releasing land ice to surge into the sea. These surges could raise sea levels by several feet in just a few years. Imagine standing on a coastline during one of these rapid melting periods. Maybe you live in a coastal camp, fishing and gathering shellfish. Each year, you notice the tides come higher. Low-lying areas that were dry are now marshes. Islands disappear. The beach where you gathered shells is now underwater. Within your lifetime, the coast retreats by miles. Your grandparents tell stories of hunting grounds that are now beneath the waves. This is not myth or legend. This actually happened. And the effects were not just at the coasts. As the ice sheets melted, enormous volumes of meltwater had to go somewhere. They formed vast lakes behind ice dams. They carved deep channels through bedrock. They created temporary waterfalls larger than anything existing today. The Columbia River Gorge in the Pacific Northwest was carved by repeated catastrophic floods from glacial Lake Missoula. Each time an ice dam broke, the entire lake drained in a matter of days, releasing a volume of water equivalent to 50 Amazon rivers. The scablands of eastern Washington state are the scars left by these floods. Massive channels, scoured deep into bedrock. Huge boulders, transported miles from their source. Gravel deposits, hundreds of feet thick. The landscape looks alien, like something from another planet. Because nothing like these floods happens today. They were unique to the end of the Ice Age, when enormous volumes of water were suddenly released by collapsing ice dams. Similar megafloods occurred elsewhere. The Baltic Ice Lake, trapped behind ice in Scandinavia, drained catastrophically around 11,600 years ago, flooding the North Sea and raising sea levels measurably. The Black Sea may have experienced a catastrophic flood when rising Mediterranean waters breached a natural dam at the Bosphorus, turning what was a large freshwater lake into a saltwater sea. This event may be the basis for ancient flood myths in the region. Let me describe what one of these megafloods would have looked like. Imagine standing near Lake Missoula, a glacial lake in Montana containing 500 cubic miles of water. The ice dam is cracking. You hear thunderous booms as huge chunks of ice break off. Then, suddenly, the dam fails. A wall of water, 2,000 feet high, begins moving, not flowing, but surging forward like a tsunami, moving at speeds up to 60 miles per hour. The roar is deafening. The ground shakes. Everything in its path is obliterated. Trees are ripped up. Boulders the size of houses are picked up and carried like pebbles. The water scours away hundreds of feet of soil and rock, cutting down to bedrock. The flood reaches the Pacific Ocean in days, discharging more water than all current rivers on Earth combined. And this happened not once, but dozens of times over thousands of years. Each time the ice dam reformed, the lake filled again, and eventually the ice dam failed again. The landscape we see today in eastern Washington is the cumulative result of these repeated megafloods. These were not small events. These were disasters of biblical proportions. Literally. Many cultures around the world have flood myths. The Epic of Gilgamesh, the biblical Noah's flood, Hindu stories of Manu, Greek myths of Deucalion. While these myths vary in details, they share a common theme: a great flood that destroyed the old world. Could these myths preserve distant cultural memories of the catastrophic floods at the end of the Ice Age? It is possible. Oral traditions can persist for thousands of years. As the ice melted and sea levels rose, vast areas of land were submerged. Doggerland, the landmass connecting Britain to Europe, was gradually flooded. At its height, Doggerland was larger than Britain itself, a land of rivers, lakes, forests, and grasslands. Archaeological evidence suggests it was heavily populated by humans and animals. As sea levels rose, this land shrank. Rivers became estuaries. Hills became islands. Eventually, around 8,000 years ago, the last remnants were submerged. Britain became an island. Sundaland, connecting Southeast Asia, suffered a similar fate. At the height of the Ice Age, it was a vast landmass, possibly home to advanced human cultures. As sea levels rose, it fragmented into the islands we see today: Sumatra, Java, Borneo, and thousands of smaller islands. Millions of square kilometers of land were lost. How many archaeological sites, how much evidence of human culture, now lies beneath the South China Sea? We may never know. The same story played out in Australia. Sahul, the combined landmass of Australia and New Guinea, was separated when the Arafura Sea flooded the land between them. Torres Strait, now a shallow sea with many islands, was once dry land. Aboriginal Australian oral traditions speak of times when you could walk to places that are now islands or underwater. These are not just myths. They are cultural memories of real geographical changes. In the Americas, Beringia was submerged. The land bridge that allowed humans and animals to migrate between Asia and North America disappeared beneath the Bering Strait. The people on either side were now separated. American populations were isolated from Asian populations. This separation would last until European contact thousands of years later. The submergence of Beringia was the final step in the peopling of the Americas. But it was not just coastal areas that changed. Inland regions transformed as well. As ice sheets melted, the land beneath them began to rebound. Remember, the weight of ice, 2 miles thick, had compressed the Earth's crust. When that weight was removed, the crust slowly rose back up. This process, called isostatic rebound, continues today in places like Scandinavia and Canada. The land rises by a few millimeters per year, still recovering from the ice that melted thousands of years ago. The removal of ice also changed weather patterns. Ice sheets create their own climate. They reflect sunlight, cooling the surrounding air. They generate persistent high-pressure systems that deflect storm tracks. As the ice disappeared, storm tracks shifted. Rainfall patterns changed. Areas that were desert became grassland. Areas that were forest became tundra. Plant communities migrated, following the changing climate. And as plants migrated, so did animals. For humans living through this transition, the world was literally transforming around them. Hunting grounds were flooding. Migration routes were disappearing. The animals they depended on were moving or vanishing. Traditional knowledge, passed down for generations, was becoming obsolete. They had to adapt quickly or die. This was a time of crisis, a time of challenge, a time when survival was not guaranteed, but it was also a time of opportunity, a time when new ways of life became possible, a time when the old world died and a new world was born. The Great Dying, Megafauna Extinction. Now we come to one of the great mysteries, the extinction of the megafauna. Within a relatively short period at the end of the Ice Age, most of the world's large animals disappeared. In North America, 34 genera of large mammals went extinct. In South America, 50 genera vanished. Australia lost most of its megafauna. Even Eurasia and Africa, which retained more of their large animals, suffered significant losses. This was a catastrophe, a mass extinction, and scientists still debate exactly why it happened. Let us be clear about the scale. These were not just a few species. These were entire groups of animals, some of which had existed for millions of years. Mammoths and mastodons, gone. All species extinct by around 10,000 years ago. Giant ground sloths, gone. Saber-toothed cats, gone. Short-faced bears, gone. Giant beavers, the size of modern bears, gone. Dire wolves, gone. American lions and cheetahs, gone. Horses in the Americas, extinct, not to return until Europeans brought them thousands of years later. In South America, the losses were even more dramatic. Glyptodons, gone. Toxodon, a hippo-like animal, gone. Macrauchenia, a creature with a camel-like body and a short trunk, gone. Giant armadillos, gone. Terror birds, predatory flightless birds up to 10 feet tall, gone. The South American fauna was decimated. In Australia, all the large marsupials vanished. Diprotodon, gone. Giant kangaroos, gone. Marsupial lions, gone. Giant monitor lizards, likely gone, though some debate continues. What is striking is the selectivity. It was primarily large animals that went extinct. Animals weighing more than about 100 pounds suffered the most. Smaller animals, by and large, survived. Birds, small mammals, reptiles, amphibians. Most came through fine. This was not a general ecosystem collapse affecting all life. This was something that specifically targeted large animals. Why? This question has generated decades of scientific debate and controversy. There are two main hypotheses, and they are not mutually exclusive. The first is climate change. The end of the Ice Age brought dramatic environmental changes. Habitats shifted. The mammoth steppe, that vast grassland that supported enormous herds of large grazers, fragmented and disappeared. As the climate warmed and precipitation patterns changed, grasslands turned to forests in some areas, to wetlands in others. The open habitat that megafauna depended on was shrinking. For animals adapted to cold, dry grasslands, this was a disaster. Mammoths were supremely adapted to Ice Age conditions. Their thick fur, small ears, and large size helped them conserve heat. They were specialized grazers, eating enormous quantities of grass each day. As grasslands disappeared, replaced by forest or tundra, mammoths lost their food source. They could not adapt quickly enough to the changing conditions. Their populations fragmented, isolated on shrinking islands of suitable habitat. Small populations are vulnerable. Genetic diversity decreases. Inbreeding increases. Random events can wipe out entire populations. A harsh winter, a disease outbreak, a drought. Any of these could eliminate a small, isolated group. And once populations became small and isolated, extinction became increasingly likely. This is called an extinction vortex. Populations decline, which makes them more vulnerable, which causes further decline, and so on, until extinction. But here's the problem with the climate change hypothesis. Large animals had survived previous climate changes. The Ice Age was not a single event, but a series of glacial and interglacial periods. There had been warm periods before. The previous interglacial, around 120,000 years ago, was actually warmer than today. Yet the megafauna survived. So why did they go extinct this time? What was different about this particular warming event? This is where the second hypothesis comes in. Humans. The overkill hypothesis, proposed by paleontologist Paul Martin in the 1960s, argues that humans hunted the megafauna to extinction. The timing is certainly suggestive. The extinctions correlate with human arrival in different regions. Australia's megafauna disappeared around 45 to 50,000 years ago, shortly after humans arrived. North American megafauna disappeared between 13 and 11,000 years ago, coinciding with the spread of Clovis people across the continent. Madagascar's megafauna vanished after human arrival around 1,500 years ago. The pattern is consistent. Humans arrive, megafauna disappear, and there is direct evidence of hunting. Archaeological sites show mammoth bones with spear points embedded in them, butchery marks on bones, kill sites where multiple animals were slaughtered. Ancient humans definitely hunted megafauna. The question is, did we hunt them to extinction? Or were we just one factor among many? The debate has become contentious, sometimes heated, because it touches on sensitive questions about human nature and our impact on the environment. Let us look at the evidence for overkill. First, large animals are particularly vulnerable to hunting. They reproduce slowly. Mammoths, like modern elephants, probably had a gestation period of about 2 years and produced one calf at a time. They took years to reach maturity. If humans killed even a small percentage of the population each year, more than the birth rate could replace, populations would decline. And once populations were small, they would become even more vulnerable. Second, these animals had no prior experience with human hunters. In Africa and Eurasia, humans and megafauna had co-evolved for millions of years. African elephants are wary of humans. They learn to fear us. But in the Americas and Australia, humans were new. The animals there had never encountered human hunters. They were naive, easy prey. They probably did not run when approached. This made them extremely vulnerable to hunting, especially in the early stages of human colonization. Third, computer models show that even relatively low hunting rates, if sustained over centuries, could drive megafauna populations to extinction. You do not need a deliberate extermination campaign. Just regular hunting, at rates that would be sustainable if populations were large and stable, becomes unsustainable when populations are already under stress from climate change. The combination of climate change fragmenting populations and human hunting removing individuals creates a lethal 1-2 punch. But critics of the overkill hypothesis point out problems. Archaeological evidence of hunting is actually quite limited. Yes, we have kill sites, but they are relatively few. If humans were hunting megafauna extensively across continents, we should find more evidence. Where are all the bones with cut marks? Where are the massive kill sites? And how could small human populations, scattered across vast territories, hunt so effectively that they eliminated dozens of species? Moreover, the extinctions were not instantaneous. They took thousands of years in most places. If humans arrived and immediately started hunting everything to death, extinctions should be much more rapid. Instead, species disappeared over extended periods. This suggests a more complex process than simple overkill. Perhaps climate change weakened populations, making them vulnerable to hunting. Perhaps human-caused changes to the landscape, like using fire to modify vegetation, played a role. Perhaps disease was involved. The disease hypothesis suggests that humans, or their companion animals, like dogs, brought new pathogens that megafauna had no immunity to, similar to how European diseases devastated Native American populations after contact. Could a disease epidemic have swept through megafauna populations, driving them to extinction? It is possible, though we have little direct evidence. Diseases rarely leave traces in the fossil record, but we know that wildlife diseases can be devastating. Rinderpest nearly wiped out African buffalo in the late 1800s. Maybe something similar happened to Ice Age megafauna. The truth is probably some combination of factors. Climate change, hunting, disease, habitat alteration, all working together. The relative importance of each factor may have varied by region and species. In Australia, where humans arrived during a time of relatively stable climate, Hunting may have been the primary cause. In North America, where human arrival coincided with rapid climate change, both factors likely contributed. In Eurasia, where humans and megafauna coexisted for much longer, other factors must have been involved. What is undeniable is that something unprecedented happened. The largest mass extinction of large animals since the dinosaurs died out 66 million years ago. Within a few thousand years, the world's fauna was transformed, and the ecosystems they left behind were fundamentally different. Grasslands, without grazers, became forests or scrubland. Seed dispersal patterns changed. Nutrient cycling changed. The extinction of megafauna reshaped entire ecosystems in ways we are still trying to understand. This was not just about losing charismatic animals. This was about fundamentally altering how ecosystems functioned. Consider what these animals did for their ecosystems. Mammoths were ecosystem engineers. They trampled young trees, keeping forests from expanding. They fertilized grasslands with their dung. They created pathways through vegetation that other animals used. Their enormous bodies, when they died, provided food for scavengers and nutrients for soil. Losing mammoths did not just mean losing one species. It meant losing all the ecological functions they performed. This is called trophic downgrading, and its effects cascade through entire ecosystems. We can see evidence of these changes today. In Siberia, frozen mammoth remains are eroding out of permafrost. These carcasses, preserved for thousands of years, give us detailed information about what mammoths ate, how they lived, even their DNA. We have found baby mammoths so well preserved, you can see individual hairs, stomach contents showing their last meals. These are not fossils, but actual tissue, frozen in time. It is both fascinating and haunting to see these magnificent creatures, knowing they represent a world that no longer exists. Some scientists dream of bringing mammoths back through genetic engineering. Using preserved DNA and modern elephants as surrogates, could we resurrect the mammoth? Technically, it might be possible someday, but would it be wise? A mammoth without its ecosystem, without the Ice Age world it evolved for, would just be a curiosity in a zoo. The world it belonged to is gone. We can preserve the memory, study the remains, learn the lessons, but we cannot truly bring back what we lost. Extinction is forever, and that is a sobering truth. Human adaptation and innovation. Now, let us turn our attention to how humans responded to all these changes. Because the end of the Ice Age was not just a story of extinction and catastrophe, it was also a story of adaptation, innovation, and ultimately, the birth of civilization. The humans who lived through this transition had to adapt to a rapidly changing world, and they succeeded spectacularly. Let us explore how. First, understand that humans at the end of the Ice Age were sophisticated, intelligent, culturally complex people. They were not primitive cavemen. They had technology, social organization, extensive knowledge of their environment. As the megafauna disappeared, humans had to adjust their hunting strategies. Mammoths had been a reliable, high-value resource. A single mammoth could provide tons of meat, hides for clothing and shelter, bones for tools and building materials, ivory for carving. Losing access to mammoths was a significant challenge. But humans adapted. They shifted to hunting smaller animals. Deer, bison, elk. These required different techniques. You cannot hunt deer the same way you hunt mammoths. You need different weapons, different tactics, different skills. Technology evolved rapidly. The bow and arrow, which may have been invented earlier but became widespread at this time, was perfect for hunting smaller, faster animals. Bows allowed hunters to strike from a distance, without getting dangerously close to prey. They were easier to use than spears, required less strength, and were more accurate. Fishing technology also improved. Bone fishhooks, nets, weirs, traps, all became more sophisticated. As large game became scarce, aquatic resources became more important. Humans also relied more heavily on plant foods. Seeds, nuts, roots, tubers. These had always been important, especially for women and children who did most of the gathering. But as the climate warmed and environments changed, new plants became available. Wild grains, legumes, fruits. A diverse array of plant foods could be collected. This required extensive knowledge. Which plants are edible? When are they ready to harvest? How do you process them? This knowledge was passed down, accumulated, refined over generations. And then something revolutionary happened. People began to settle down. During the Ice Age, most humans were nomadic. They followed animal migrations, moved with the seasons. But as the climate stabilized and certain resources became reliably abundant, some groups began to establish permanent or semi-permanent settlements. Why wander if you can stay in one place where food is plentiful? The first signs of this appear around 15,000 years ago in the Near East, in a region called the Levant. The Natufian culture, which flourished between about 15,000 and 11,700 years ago, built permanent villages. These were not temporary camps, but substantial structures. Circular stone houses, storage facilities, communal buildings. The Natufians harvested wild grains intensively. They developed sickles with stone blades for cutting grain. They had grinding stones for processing seeds. They stored surplus food for leaner times. This was not yet agriculture, but it was moving in that direction. Why did people settle down? Multiple reasons. In areas where resources were abundant and predictable, settling down made sense. You could invest time and effort in building better shelters, developing storage facilities, creating more complex social structures. Sedentary life allowed populations to grow. Nomadic groups are limited in how many young children they can transport. But if you are settled, you can have more children, spaced closer together. Population growth and sedentism reinforced each other. But sedentism also brought challenges. Disease spread more easily in permanent settlements. Sanitation became an issue. Conflict increased as groups competed for the best locations. And there was pressure to increase food production to support growing populations. This set the stage for the next great revolution: agriculture. The domestication of plants and animals was one of the most important transitions in human history. And it happened right at the end of the Ice Age, made possible by the climatic changes we have been discussing. Agriculture did not happen suddenly. It was a gradual process of experimentation and adaptation over thousands of years. The Fertile Crescent, a region stretching from the eastern Mediterranean through Mesopotamia, was one of the earliest centers of agriculture. Wild grains, like wheat and barley, grew abundantly here. Around 11,500 years ago, people began to deliberately plant seeds, water plants, protect them from animals. This was the beginning of cultivation. As people selected which plants to save for seed, they were unconsciously changing the plants themselves. Seeds that did not disperse easily, that stayed on the stalk where they could be easily harvested, were selected over seeds that fell off naturally. Grains with larger seeds were preferred. Over generations, domesticated plants evolved to look quite different from their wild ancestors. They became dependent on humans for dispersal and survival. Humans and crops entered into a symbiotic relationship. Animals were also domesticated. Dogs were first, probably domesticated from wolves during the Ice Age, possibly as early as 30,000 years ago. They helped with hunting and guarding, but at the end of the Ice Age, other animals followed. Goats and sheep were domesticated around 11,000 years ago in the Near East, cattle around 10,500 years ago, pigs around 10,000 years ago. These animals provided meat, milk, hides, wool, labor. They were walking food stores. Agriculture spread from these early centers. Not always by migration, though that happened. Often by cultural diffusion. Neighboring groups saw the success of farmers and adopted the practice. Within a few thousand years, agriculture had spread across Europe, into Africa, across Asia. Independent centers of agriculture also developed elsewhere. In China, rice and millet were domesticated around 9,000 years ago. In Mesoamerica, maize, beans, and squash around 8,000 to 9,000 years ago. In the Andes, potatoes and quinoa. In New Guinea, taro and yams. Agriculture was revolutionary because it allowed much higher population densities. A square kilometer of farmed land can support far more people than the same area used for hunting and gathering. Populations exploded. Villages grew into towns, towns into cities. Complex societies developed. Specialized occupations, social hierarchies, organized religion, writing systems. All of this emerged from the agricultural revolution, and that revolution was made possible by the end of the Ice Age. But agriculture also brought problems. Dependence on a few crops made populations vulnerable to crop failure. Disease spread more easily in dense populations. Inequality increased as some people accumulated wealth, and others did not. Warfare intensified as groups competed for land and resources. Skeletal evidence shows that early farmers were often less healthy than hunter-gatherers. Shorter stature, more dental problems, signs of nutritional stress. Agriculture was not an unalloyed blessing, yet once started, agriculture was hard to abandon. Populations had grown beyond what hunting and gathering could support. People were locked into farming, even if it meant harder work and poorer health. This is sometimes called the agricultural trap, but it also drove further innovation. Better tools, irrigation systems, crop rotation, animal breeding. Farmers constantly worked to improve yields. This cycle of problem and solution drove technological advancement. Not all humans adopted agriculture. Many groups remained hunter-gatherers for thousands of years after agriculture was available. In marginal environments where farming was difficult, hunting and gathering remained the best strategy. In rich environments where wild resources were abundant, there was no need to farm. Australian Aboriginal peoples, for example, never adopted agriculture despite thousands of years of contact with agricultural societies to the north. Their way of life was sustainable and satisfying. Why change? But in most of the world, agricultural societies expanded, pushing hunter-gatherers into marginal lands. Farmers had numbers on their side. They could support larger populations, field larger armies, outcompete or absorb hunter-gatherer groups. This process continued for thousands of years and is still happening in some places today. The spread of agriculture was one of the great population replacements of human history, and it all started at the end of the Ice Age, when the warming climate made farming possible. The changes were not just technological and economic, they were social and psychological. Settled agricultural societies developed concepts of property ownership. Land belonged to someone. Resources were owned. This was different from the more fluid, shared resources of hunter-gatherer societies. Hierarchy deepened. Chiefs, kings, priests, positions of power and authority emerged. Writing systems developed to keep track of resources, to record transactions, to preserve information. The earliest writing, in Mesopotamia around 5,000 years ago, was mostly economic records. Civilization, as we usually define it, was emerging. Looking back, we can see the end of the Ice Age as a great transition point in human history. Before, small groups of mobile hunter-gatherers living in a world of megafauna and ice. After, settled agricultural societies heading towards cities, states, and civilization. The world of 12,000 years ago was on the cusp of this transformation. The people living then could not have known what was coming. They were just responding to immediate challenges, finding food, adapting to changing conditions, surviving. But their responses set in motion changes that would transform humanity forever. Think about the psychological impact of living through such changes. Your great-grandparents tell stories of hunting mammoths. Your grandparents remember when the coast was miles away. Your parents saw forests replace grasslands. You are learning to plant seeds instead of following herds. The world is literally transforming within a family's memory. How does that affect your worldview? Your understanding of permanence? Your sense of what is possible? These were people living through revolutionary times, even if they did not have words to describe it. And the innovations were not just practical, but conceptual. The idea of storing food for the future, the idea of owning land, the idea that humans could control nature by planting and tending crops. These were revolutionary concepts. They required a different way of thinking about the relationship between humans and the environment. Hunter-gatherers live in the present, responding to what nature provides. Farmers must plan for the future, investing labor today for returns months from now. This shift in temporal thinking was as important as any technological change. What this tells us about today. So why does this ancient history matter today? Why should we care about events that happened 12,000 years ago? Because the end of the Ice Age teaches us crucial lessons about how Earth's climate system works, how ecosystems respond to rapid change, and how human actions can have far-reaching consequences. These lessons are directly relevant to the challenges we face today. Let us explore these connections. First, the end of the Ice Age shows us that Earth's climate can change dramatically and rapidly. We often think of climate as stable, changing only slowly over millions of years. But the ice core records show otherwise. Temperatures at the end of the Younger Dryas, for example, rose by about 10 degrees Celsius in Greenland in just a few decades. That is extraordinarily rapid. Entire ecosystems had to adapt or die. The lesson: climate is not as stable as we might think. It can shift suddenly, and when it does, the consequences are severe. We are currently experiencing rapid climate change due to human activities. The parallels to the end of the Ice Age are unsettling. Second, the Ice Age ending shows us the power of feedback loops. Small initial changes were amplified by feedbacks. Ice albedo feedback, carbon cycle feedbacks, ocean circulation changes. These feedbacks can make climate change accelerate. Today we are seeing similar feedbacks beginning to operate. Arctic ice melting exposes dark ocean, which absorbs more heat. Permafrost thawing releases methane and CO2. Amazon rainforest becoming drier and more prone to fire, releasing carbon. These are positive feedbacks that could accelerate warming beyond what our models predict. Third, the megafauna extinction demonstrates that even species that seem invincible can disappear. Mammoths and saber-toothed cats dominated their ecosystems for millions of years. They survived numerous climate changes, but when faced with rapid environmental change combined with human pressure, they went extinct. Today, we are in the midst of another mass extinction. Species are disappearing at rates hundreds of times faster than the background extinction rate. Large animals, again, are particularly vulnerable. The parallels are clear. Fourth, the end of the Ice Age shows that human impact on the environment is not new. Our ancestors 12,000 years ago, with nothing but stone tools and fire, may have played a role in driving dozens of species extinct. They altered landscapes with burning. They overhunted. They changed ecosystems. If Stone Age humans could have such impacts, imagine what billions of modern humans with industrial technology can do. We are not separate from nature. We are part of it, and we have always altered it. Fifth, the transition to agriculture shows both the benefits and costs of intensive resource use. Agriculture allowed population growth and civilization, but it also created vulnerabilities. Dependence on few crops, epidemic diseases, environmental degradation. Today's industrial agriculture faces similar challenges. Monocultures vulnerable to pests and disease, soil degradation, water pollution. The lessons from the origins of agriculture remain relevant. Intensive resource exploitation brings short-term benefits but long-term risks. The flooding of coastal areas at the end of the Ice Age is particularly relevant today. Sea level rise displaced millions of square kilometers of land. Coastal populations had to retreat inland. Today, with billions of people living in coastal zones, future sea level rise poses an enormous challenge. Even a few feet of rise would displace hundreds of millions of people. The end of the Ice Age shows that such changes are possible. They have happened before. They can happen again. And the social disruption would be immense. But the end of the Ice Age also offers hope. Humans survived. We adapted. We innovated. We found new ways to live in a changed world. Yes, it was difficult. Yes, there were losses. But humanity came through. We are resilient. We are creative. When faced with challenges, we can change. The key is recognizing the challenge early and responding appropriately. Our ancestors did not have climate models or satellite data. They could not predict what was coming, but they adapted as changes occurred. We have the advantage of foresight. We can see changes coming. The question is, will we act? The Ice Age ending also reminds us that the world we consider normal is actually unusual. The Holocene, the warm period of the last 12,000 years, is an interglacial, a brief warm interval between ice ages. For most of the last million years, Earth has been much colder. Ice ages are normal. Warm periods are brief. We live in one of these brief, warm periods. And the climate stability of the Holocene, which allowed agriculture and civilization to develop, is not guaranteed. We are fortunate to live in this stable period, but stability is precious and fragile. One interesting question: without human-caused greenhouse gas emissions, would we be heading into another ice age? Some scientists think so. Orbital cycles suggest we should be slowly cooling, heading toward the next glacial period over the next few thousand years. But human emissions have interrupted this natural cycle. We have added so much CO2 to the atmosphere that we may have delayed the next ice age by tens of thousands of years. We have become a geological force, capable of altering planetary climate cycles. That is both amazing and terrifying. The end of the ice age also teaches humility. The megafauna were dominant for millions of years, yet they vanished. Ecosystems that seemed permanent transformed completely. Landscapes changed beyond recognition. Nothing is permanent. Everything changes. The world our grandchildren inherit will be different from ours. The question is, different in what ways? Will it be a manageable transition or a catastrophic collapse? That depends on choices we make today. We cannot stop change, but we can influence its direction and speed. Finally, the end of the Ice Age reminds us of deep time. 12,000 years seems like a long time ago, but in geological terms, it is yesterday. The mammoths walking across North America are not ancient history. They are recent. Our species has been around for 300,000 years. Civilization for only 5,000. We are newcomers. The planet has seen changes far more dramatic than anything we have experienced. Ice ages lasting 100,000 years. Warm periods with no ice anywhere on Earth. Asteroid impacts, supervolcano eruptions, Earth endures, life adapts. But individual species can vanish. Civilizations can collapse. We are not immune. Understanding this history gives perspective. Our current climate crisis is serious. The extinctions we are causing are real, but Earth has been through worse. Life will continue. The question is, will we be part of that future? Will we adapt successfully? Or will we, like the mammoths, prove unable to adjust to rapid change? The answer is not predetermined. We have agency. We have choice. The people at the end of the Ice Age did not choose the changes they faced. We, at least partially, are choosing ours. That gives us both responsibility and power. The question is, how will we use it? Conclusion. Let us recap this extraordinary story. 12,000 years ago, Earth was a very different planet. Massive ice sheets covered vast areas. Sea levels were 400 feet lower. Mammoths and saber-toothed cats roamed landscapes that no longer exist. Humans were small bands of hunter-gatherers, living in a world dominated by ice and giants. Then, triggered by orbital changes and amplified by feedbacks, the ice began to melt, rapidly, catastrophically. Within a few thousand years, the world transformed completely. Glaciers 2 miles thick vanished. Sea levels rose, drowning vast areas of land. Megafloods carved new landscapes. Coastlines retreated. Islands appeared and disappeared. The climate shifted from Ice Age cold to modern warmth. Ecosystems collapsed and reformed. Grasslands became forests. Tundra became grassland. Desert became savanna. Every ecosystem on Earth was affected. Nothing stayed the same. This was planetary transformation on a scale difficult to comprehend. And the megafauna disappeared. Mammoths, mastodons, saber-toothed cats, giant sloths, cave bears. Dozens of genera went extinct. The causes are still debated. Climate change, human hunting, disease. Probably all three played roles. But the result is clear. The magnificent giants of the Ice Age vanished. The world they left behind was emptier. Ecosystems functioned differently without them. We still live in that diminished world. The megafauna are gone. They are never coming back. But humans survived. More than survived. We thrived. We adapted to the changing world. We developed new technologies, new strategies. As the megafauna disappeared, we shifted to hunting smaller game, to fishing, to gathering plant foods more intensively. As the climate stabilized, we settled down. We began to farm. We domesticated plants and animals. We built villages, then towns, then cities. We created civilization. All of this emerged from the crucible of the Ice Age ending. This is not just ancient history. This is the foundation of our modern world. Every city, every field of wheat, every domesticated animal, every aspect of civilization traces back to choices made by people at the end of the Ice Age. They could not have known what their decisions would lead to. They were just trying to survive, to feed their families, to adapt to a changing world. But their responses set in motion changes that led directly to us, to this moment, to everything we recognize as human civilization. And the lessons from this time are directly relevant today. We are living through another period of rapid environmental change. We are causing another mass extinction. We are altering climate through our emissions. The world our children inherit will be different from ours, just as the post-Ice Age world was different from what came before. The question is, will we adapt successfully? Will we make wise choices? Or will we, like the megafauna, prove unable to adjust quickly enough? The end of the Ice Age teaches us that change is constant, that species can vanish, that ecosystems can transform, that coastlines are temporary, that climate is not stable. But it also teaches us that humans are adaptable, that we can innovate, that we can survive difficult transitions, that crisis can drive creativity, that endings can also be beginnings. The end of the Ice Age was the death of one world and the birth of another. We are living through something similar. How it turns out depends on us. Imagine if we could speak to those people 12,000 years ago, standing on a coastline, watching the sea rise, watching the megafauna disappear, watching their world transform. What would we tell them? That their descendants would build skyscrapers and spaceships? That we would number in billions? That we would have the power to alter the planet itself? They would hardly believe it. And what would they tell us? Perhaps this: that survival requires adaptability, that change is inevitable, that the old world must die for the new to be born, that endings and beginnings are the same thing. The story of the Ice Age ending is ultimately a story about transformation, about how the world changes and how life adapts, about death and birth, endings and beginnings. It is a story about our past, but it is also about our future, because we are living through another transformation, another moment when the old world is dying and a new one is being born. What that new world looks like, whether it is a world we would want to live in, depends on choices we make today. The people at the end of the Ice Age did not choose their challenges. We, at least partially, are choosing ours. May we choose wisely. Thank you for joining me on this journey through time. The end of the Ice Age was one of the most dramatic periods in Earth's recent history. A time of catastrophe and opportunity, of death and rebirth, of endings and beginnings. Understanding it helps us understand where we came from and where we might be going. The mammoths are gone, the ice has melted, the world has changed, but the lessons remain. Change is constant. Adaptation is essential, and humanity, for all our flaws, is remarkably resilient. We survived the end of the Ice Age. We can survive what comes next. If we learn from the past and act with wisdom and foresight, the story continues, and we are writing it now.